Hi, this is Professor Tiffany Martin with Medical Microbiology, and we are in Chapter 7, Microbial Genetics. And we have just finished talking about strand separation during DNA replication, and now we just need to see what happens next. So let's go back to the whiteboard, and this is what's happening after strand separation. Helicase has been unzipping, topoisomerase is up here, and then we've got our single-stranded binding proteins. All right, so the next enzyme that's going to be involved is called RNA primase. An RNA primase is an enzyme that is looking for single-stranded DNA. And when it finds single-stranded DNA, it will pop off these single-stranded binding proteins, and using complementary base pairing, will lay down a ribonucleotide, so a piece of RNA that's complementary to the DNA here. So this is the job for RNA primase, the enzyme. It's looking for single-stranded DNA, and it's going to use complementary base pairing to match it with a ribonucleotide. So if this was a G, it would put a C. If this was a, it would put a U for uracil, and create a piece of RNA right here. And we're going to call this RNA, it's going to be called a primer. And it gets this process started. RNA primase lays down about 12 to 15 nucleotides, and then it falls off. So it's just a little short piece of RNA right here. So it has this RNA primer. All right, so what's the next step? The next enzyme that's coming in is called DNA polymerase 3. So DNA polymerase, it's an enzyme, ACE, and what is it going to do? It's going to polymerize DNA, which means it's going to build or make, synthesize DNA. It's called polymerase 3 because there's some other ones in there. So this is the DNA polymerase 3's jobs. We'll get rid of all the single-stranded binding proteins there. All right, so what DNA polymerase 3 is looking for is a section that's double-stranded followed by a single-stranded section. And he's going to add a nucleotide to this primer that started making. He's going to add a DNA nucleotide, deoxyribonucleotide to this DNA. But remember when we talked about the structure, we said that 3' end is important and it can only add to that 3' end. So we need to figure out where the 3' end is. And I've labeled my original DNA structure 5', 3', 5', 3'. So what's my orientation of my primer? If this is the 3' end here, then I know this is the 5' end of that anti-parallel RNA. So here's my 3' end with that 3' hydroxyl. That's what DNA polymerase 3 is looking for. Double-stranded with this 3' hydroxyl so he can add in the nucleotide there. So he's going to bind there, and he's going to start adding in nucleotides using complementary base pairing and creating a strand of DNA. He's replicating, right? So there's the next 3' hydroxyl. He'll add the next one in, and then so on and so on until there's no more single-stranded DNA. Once he binds, he stays on there and he does his job until he can't do it anymore. All right, so that's the job of DNA polymerase 3. Now there is another DNA polymerase that's involved with this. Again, it's a DNA polymerase that polymerizes or builds DNA, but instead of looking for double-stranded followed by single-stranded, he is actually looking for DNA polymerase 1 is looking for RNA. And he is looking for any RNA that is there, and his job is he binds to the RNA, he excises it, and replaces it with DNA. And he will continue to do that until the RNA primer is gone and he has replaced it with DNA. And he'll ligate it all and put it all back together from that. So that's the job of DNA polymerase 1. Okay. All right, so this is how it's starting, that replication, and we're going to learn about this one in a minute, but let's focus on the jobs of the enzymes and what they do. So going back to the PowerPoint, let's review. First thing that has to happen after strand separation is RNA primase comes in, And the enzyme RNA primase is going to add ribonucleotides until it has a piece of RNA that's going to serve as a primer or an anchor for DNA polymerase 3. DNA polymerase 3 comes in, and he's looking for that double-stranded followed by single-stranded. He's looking for that 3' hydroxyl, and he's just going to keep adding nucleotides. He's the big workhorse in this procedure, in this process. Now, we can't forget about those pieces of RNA. It's the job of DNA polymerase 1 to find those pieces of RNA and remove them and replace them with DNA. Now, there's one other enzyme. We're going to come back to him, so hang on to him. But that's the first part of this reaction. So I want you to go back through using the figure and work over that. And we're going to stop this video here. And when we come back, we're going to see what happens on the other side. This first side is called the leading strand. And then the next video is going to talk about the lagging strand.